Good afternoon. Sorry, I have a problem. I start up things like this, and then I look for pens and papers, and then I start tying wires together, and I barely know what I'm doing, but I I need to get a handle on myself and actually start doing things. I know for this session I wanted to finish up the flag system and start writing the make files and everything. So let's do that. Let's open up MX Shell and let's go to project slash blah blah crap. I might use diode mode. Diode mode is fine. Let me open CX5C. Go in here. This is not the shell buffer. Actually, CX50. Okay, CX50. I need to do CX52, CXD on this directory, and this mode does everything I need here. This is like just for all the management places. Now I do 652. Go back in here. This is diode mode. Now I gotta find the flags. So I'm just gonna find flags, and flags has no changes, and settings has no changes. Flags.cpp, right? Oh, you only resize this? Okay. Okay. I got the code here. Let's start up something. Let me get a clock so I can remember reality. Ah, better. At least this isn't like a clock where it has like a memory leak every once in a while. That's something about GNU/Step. It's not exactly the most stable environment. I like how this looks, but liking how something looks changes from time to time. I could open up Mate. In fact, I feel like a distro hopper when I switch from different desktop environments. I mean, are they not any different? One's hopping between operating systems and the other's hopping between interfaces. And if you think about it, an operating system is an interface. A bigger and more convoluted one that includes other interfaces to other things, but they're both interfaces when you consider them in that light. Hold up. Okay. I need a sanity check. So I have my notebook open here, and I got my wires tied up. So, so the stages here we have from call. We already registered call at the function main. Then you go to the flag and data sequence, and then the filtering process, and then the parser. The parser's an entirely separate entity. That's what we know. Now here, once you transition from one thing to another, that's important. So flag and data sequence, that's important. Filtering, that's also important. Actually, filtering is not important. Filtering is an option that we choose to do. We can choose to put in some filters. We can choose to take out some filters, but that stays in the implementation of our flag system. I know somebody's going to ask me, why didn't you just use ncurses? Your life would have been so much easier. I'm not trying to use ncurses. I'm trying to be smart, and I have an ego. And I have this silly little thing called I want to learn how things work. So flag and data sequence, this just creates a sequence of symbols, and these symbols are attached to the string. So ultimately we still have a vector of strings, a vector of strings, objects labeled flags and not flags. But actually, they come into a larger process, and that is creating something, just a pure sequence that the parser can take in. Basically, like digesting things for the parser. Finally, I don't need to go any further. Okay, so the stages of this. First, you take in the flags. They can usually be letter, 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 and data, then letter, letter, data, 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 data. Okay. Cool thing about data, you don't need to do anything about it. You just ignore it. You put it into the sequence in its place. However, flags come in multiple forms. They can come in one letter forms. They can come in a stack of one letter forms. Right? Then they can come into a long form. And after long form, there's nothing else. Now, I know how I filtered this. I went through with a solution called... Okay. I went through and with a solution for sequence filter here. Sequence filter took the existing sequence and it wrote a sim for every time. If it wasn't a word, and by some magical logic, I don't like this part. By some magical logic, we found that it was at least a valid flag. Then we can say, you know, we can for every letter in there, we assign its synonym there, and we punch it in the order that is. So that's good. Yeah. Oh, this is hard. No, not hard. So we know all of this goes into the filter sequence. We take the short thing, we get the sequence. We don't care whether it supplies data or not. We just know it's that and it's that. So the algorithm here is kind of like a key, right? Data or flag. Now flag is a more convoluted one, right? Flag. 1 dash or 2 dash? 2 dash is the end. Right? Then 1 dash. 1 dash is kind of iterate. And add synonym. Or we could adopt a different system. That system, put this back, we don't need this. We could adopt a different system, and that system is we can have duplicate flags that mean the same thing. They go to the same setting. I'm not sure what advantage this would have. Would it simplify things? It would simplify things. Simplifying in one aspect makes it complex in another. So if you iterate and you add synonyms, add the synonym, then the parser will only have to deal with 2 dash letters. That means it's all a common format. That means writing the parser will be easier. However, if we keep 1 dash, the parser will also have to account for both types. Accounting for both types twice is not quite epic in my opinion. So we're going to carry on with the idea that we had before. So this is basically the thing. So key, data flag, 1 dash, 2 dash, that synonym, and after that you get a sequence. After this, you get points. Sequence needs to be parsed by a parser. It goes into a parser, right? And the parser needs another thing, that is the environment, what the flags we've set up, and the settings. So each flag will have a setting attached to it, has a certain value, setting, and then these settings correspond to a table of notch. This is table flags. You can call like a program environment, basically how you interact with the program. And this table of flags goes into the parser. Parser needs access to these at all times, and they also require a sequence. When they get a sequence, they'll interpret it with respect to the environment, and after that, use the flags. They will use the flags. Parser will create actions or calls, basically that translate to the flag. And the flag will send that to the settings, the individual settings which have tables for them. Now I will reduce the redundancy at the end for trivial choices. Once it goes into the parser, everything is marked with everything that is marked as flag and not flag. We'll remove the dashes in the filtering stage. So by the time the sequence goes into the parser, it actually doesn't just get strings. It gets strings that are marked as flags, long flags. Actually, all of them are long flags. It all gets marked as long flags. So it's a flag and data, flag and data, flag and data. Same thing we did in the beginning. In the middle, gonna do a couple of things that we don't need. The intermediate representation during the filtering stage is it's very short-lived. So if something's a short flag or a sequence of short flags, it turns into a long flag. By the time it hits the parser, we don't need to make a representation. It's fine if we keep it stored in functions. So then this is like a sequence of flags and options and such. That way, when the flag gets removed, after that, flags and the data that they hold are actually tied. Flag call objects, and these call objects are set to the flags themselves. And then the flags use that to manage something else. So, I don't know if we should make a call object. I think it would be a little bit better to just make a call to the flag or ask the flag to send something. And depending on that kind of flag, it'll probably expect data or won't expect data. So flags can do what they like. So it's just a parameter, basically, a call to the flag. So that's the interface. So what we can take from this, we have a set of processes, basically, that take in this thing and filter it for a parser. That parser will make calls to flags. Flags are objects that actually are in their representation just settings. So the main objects we have are parser and flags. We already have the settings figured out. But now we need to see the flags, the parser, and the other part, the filtering sequence. The filtering sequence, I don't know how we should represent that. Should we represent it as a filter object, wherein we can map a function over something, or a series of keys? Perhaps, we can create a set of functions that operate over a sequence that eventually filter them, and then these functions are held in the filter in like a sieve object. So this all goes into the sieve, and the sieve manages all of its little functions, its chain of functions, and puts them all together, produces you an output. That's the sieve function. We'll go with a function on this part. The parser object, I'm not sure what I would do here. I think a class with static functions is okay. This isn't functional programming. I'd love it to be functional programming. This would be amazing to write as a functional program, but we have to write it like this. The parser is definitely an object. It needs an environment that we need to hold for it. So if we combine the data and the processor into one, that's fine. We're nice and done with the parser. We're certain that the parser fills all the requirements for an object. C++ ain't really nice. I mean, the way that most people learn it's like, okay, you go into object, into functional programming, go with the Pascal boys, go with the Lisp boys, go do something like that. I mean, maybe I don't know that you can put functional and OOP programming together. Maybe I'm just too like I got a shell around my walnut brain, the walnut. Now, uh, why not? Let's just write it as a class. There's nothing wrong with that. There's nothing wrong with it being a class. So let's write the first stage, which is filtering. We want to get strings. We know we're going to be working with only const char strings. We'll convert these later on to std strings. Do we need to name them as std strings? Well, we'll have to move them to stds. We wrote settings as a template. We could write it using const chars, right? I have to look back into settings. Into the settings function. Everything with that value, it just searches. It just searches. So any null terminated series of characters, that's fine. If it works, it works. If it don't work, we'll convert it to string later on. Then, okay. Let's start the rewrite. Let's erase all of this. Have the algorithms written down anyway. Did we do it? Let's do it. And all the way here. This is the better part. We start with stage 1. We need to define a pair of a struct. And this struct is, so we need to do with type def. String type. Type def statements. I remember how to do type. I knew how to do type def statements yesterday. So let's see how I wrote it this way. Type def const char this as a string, or actually char pointer. We don't need this. We don't need this. So this is a struct. This is symbol. And in each symbol, we have an underlying string. And we have an email called a marker. Data is I need to look through documentation. I'm back. I found the documentation. It's not how you write a that's fine. So this is what a marker looks like. It is symbol. Okay, symbol will also have, okay, this is type. The symbol is its type. Now we want a class object basically called a C. Class C public function. Here, what do sieves need? Sieves don't need anything, actually. They're just objects that you create for dealing with things like this. So sieve constructor, if we need it, we'll write it. Then we can write private, and here we can have a function that returns a type of sequence. So a sequence is also a structure that we need to make ourselves. And this sequence is just a sequence of vector symbols. So here, type def std vector of symbol, and this will function that returns a sequence called filter. Now filter will just take an C and char double char pointer on V, and it'll do with it. So the first type of sequence, so really we actually will put the data inside the sieve. So double char V is the best representation. No, you can do better. We can take this int argc and char argv, and we can create them into an array, and we can start using std string instead, which will be easier to handle. I don't know if it's possible. I'm kind of scared of writing a vector of C strings. Sounds weird. Let's just use the std. So in argc, and what the constructor will do, it'll take functions, basically context for a function called load. The same thing that this takes, and void load will go into the std added. Loads will go into the arguments, which we will go with ourselves. So C will call load on int argc and char argv to do such a thing itself. Then we have a function called sequence. Filter will do absolutely nothing but filter, as clearly the name states. So here in filter we can write some functions that will manipulate how things work. So we'll have to take each char of v and initialize a string with it. With each string we'll add that to arguments. So the first of the functions will be to categorize. The filter function will first have to create intermediate sequences. We'll take the sequence function first, which is to categorize this into either data or flag. And then what is a flag we need a single function without a sequence in a sequence. So elements of the sequence can be mapped in. This will basically put the flags will be expanded, so we can just send it like a symbol. And these are the two functions. So it will first call categorize, and then it will call expand flags on whichever element of the flag that input is. It'll take that sequence and jam it into the place where that was, replacing it. And then after that, we'll have a sequence, perfectly nice, iterate and add synonym algorithm. So when you expand a flag, any small one-letter flag, we do need some functions to represent whether something is a flag or a word, basically, to categorize. So the full flag of an std string given that would be something like this, and we'll have bool data of std string string. Right? Then we want a function that tell us if we have like 2 at the beginning or like it. So if something is a flag, then we want to see if it's 2 dash or 1 dash. So 2 dash on std string string. Better not stand for something weird. And 1 std. And here fractionist. Okay, now that it's 1 dash or 2 dash, then for any one of these that goes into 1 dash and shows that, we have to iterate and add a synonym. So just iterate over them and expand. So categorize will just be a front end for flag data, and it will make a sequence. It's a basic sequence. Then in that, whichever one is a flag, we categorize into 1 dash or 2 dash. And if it's 1 dash, we expand it and add synonyms. So expand a flag, expand flag, no, not flag, expand flag. You take a symbol here. We need a synonym table. So how would we represent a synonym table? We will need another thing. So we can write C as a basic here, then C implies C. Then we can initialize C with a synonym table. And the synonym table is just an std unordered map. Type that as ordered map with type. The first type, the key type. Well, the key type and the other type are also the same. So the key type is a char. Right, the key type is char. The other type is std string. So each character corresponds to an std string, and then we'll say this is a synonym synonyms table. I'll write synonym table. Maybe I should have written cinnamon, but a synonym table is fine. We're only using it so many times. So I have an std vector of string. This is basically like a sequence, and we'll also have a synonym table synonyms. That's funny. So, we have a synonym table, and then we have a SD vector of documents. Okay, so we'll take that. So it'll ask that'll be not set synonyms. So just take this and go for that's the alternative for the constructor. Once you set those synonyms, and once you do expand flag, we'll compare each one with the synonym. And once that's done, we'll expand the flag and return a little sequence, and we insert that sequence into the larger sequence. So we don't need these intermediate representation things. And once we have expanded everything and iterated and added synonyms, we have a final sequence, which is returned as filter. And filter, very nice. Once you do filter, you get a sequence that can go into the parser. And in the parser, we can deal with our beautifully written settings, templates, and then we can see how we should write flags. And flags are quite easy, right? Flags can be an unordered map. You'd say like an unordered map of like a string that matches each one. And then with that match, that would be a struct, basically like just holds like a setting pointer and a bool. Pointer bools, pointer bools, pointer bool, such and such. And then we call those flags in a certain way. The flags could be a class or something, or a struct. It could always be a struct. I mean, we use symbol as a struct. Symbol is wrong, actually. We are not using construct string. We are using std string. Main and type. Okay, let's get implementing and let's get writing. And let's get with some of these predicate functions. The predicate functions are going to be the easiest ones to do. It's good that we've written a filtering part. Let's also write the. I don't know. I mean, biting off more than I can chew. I'm gonna have to finish the whole sandwich anyway. Class. Sir. Public. God, I hate constructors so much. No. I'm not gonna make myself suffer. Let's go take a break, look at the sun for a minute, and I'll come back. Back again. I took my break. Let's implement this. Epic music. Start. Wait a minute. I need to delete this. I've reversed the montage. Cut this out. Yeah. Okay. Well, let's start. Mm. This should get it. This should get it to work. Then, uh,
Can you fill up the water?
okay, I'm back. Just writing these functions. All of these have been written. Find synonym. I have a particular issue with this one. Specific. All the other ones are fine except for this and expand. Find synonym has the case of that have not been filled in. In that case, we might have to throw an error. So throwing error feels like a more convenient method of dealing with the problem. And it also works with like logging. We could also tie it into logging and such. All quite fun. Now we have to go back into the filter function. So we're going to have to say sequence, not um, not filter, but rather first sequence is equal to category. Then return for std sequence. It is right. Iterator. Um, yeah. Okay. Sequence iterator. In this condition, I won't write sequence iterator. It's quite weird. Familiar with that. Where's the filter function again? Okay, for std onboarding char iterator I which is equal to this is synonyms std string iterator. What kind of iterator are what are we iterating over again? We're iterating over what a sequence is, and sequence is a symbol. So std iterator I to that again. Let's we could instead write a while. We could write a while loop. We decided on not inserting things into things. We wanted to write a new sequence. So this is actually first. And read until the iterators work. Sequence expand on simple push back expand on they should just add that part and add that part, or you should write the concatenation operation since they're going to be sequences to each other. So keep, you know, adding and adding and adding and adding and adding, and eventually everything's going to be all fine. And then after that, you can say, uh, "This is the best implementation I could come up with. Maybe there's another way of doing it. Maybe I should have done a while loop. Maybe I should have went from one part to another without consideration for the final part. Um, I still don't know how the standard library works. I just sift through it to make sure I'm using it the right way. Or maybe there's a better algorithm for this. Again, I could always refactor parts of it. That's the most important part of this is that I can refactor it. So I've written the constructors, I've written load and set synonyms and filter and predicates and get mark and find some them and such. A synonym, sorry, a C doesn't need to know how the flags are organized. It just needs to know a synonym table. I think I wrote this quite well. Right, a third constructor taking synonym table and double, combining the previous one, just to make it the most possible. Then it can say no. Then after that, set synonyms. All quite nice. Very good function. We did something. See how much time that took? Probably like about 1 hour. Okay. So yeah, like an hour to an hour 30, like say hour and a quarter, give or take, actually spent doing real work. Let me just hold it here. So this is just about everything. I have all the sequence code organized, so the sieve part has been finished. Let's just cross that out. Take it, so not cross, take the sieve, then the sequence. Oh no, the sequence is put into the parser. Then the parser needs flags, so I need to write a flag. How do we write flags? We need to write maybe an array. I mean, if we're using STL, let's use STL. Stick to it. There's a standard array that we use. Use a vector. Footers are in use case. Flags, we just set them once. We turn them in. I need help, but do I use an array? This is about like the brand that I had when I did the first vlog. Do I use for getting my flags? So that the flag is stuck. Nothing. Remember, we're search function. So we're doing so. You need to make them. Nice. Yeah. Let's make another unordered map, I guess. So type cd map std string to flag. So we're gonna make a string for b flag data. For a flag, we just take a bool. Accepts data. Accepts data folder. This is for only trailing ones. Then you'd write maybe setting setting pointer. I have a problem. We need to check if we can make pointers to template types of any type. Is this possible? Like the settings are templates; they can vary. Very difficult. This is hard. I'm gonna take a break and come back from this. I need to look through documentation. I need to get smart about this. So I'm just gonna remove this incomplete part. Stick with this. Let's go back into the shell. Hit status. Got see. We can see this. Let's go grid add cpp h. Get the status again, and we got them all added in. That's gonna stay in there. I'm going to think about it a little harder, a little better. Yeah. Well, I guess this is it. This is the end. I'm gonna close this and I'm gonna come back soon. Signing off. This be it, my friends. Ciao.